If your eyes or skin start turning yellow, it all traces back to one single molecule. But here is the secret most people don't know. The blood test for that molecule can actually pinpoint exactly where your body's plumbing has broken down before you ever get near an ultrasound or a scan. That molecule is bilirubin. In this video, I'm going to walk you through exactly where it comes from, how your liver processes it, what the two different forms on your blood test actually mean, and the classic three-way framework we use in the lab to figure out exactly where things have gone wrong. Let's get into it. To read a bilirubin result, you have to follow the pathway. It all starts with your red blood cells. Red blood cells live for about 120 days. When they are worn out, they get broken down mostly in the spleen. Inside each red blood cell is a protein called hemoglobin, and when that gets broken apart, one of the byproducts is a green molecule called biliverdin, which is quickly converted into bilirubin. At this initial stage, it's called unconjugated bilirubin, sometimes labeled indirect on a lab report. It's completely fat-soluble, which means it can't just float freely in the blood. It has to bind to a transport protein called albumin to safely ride through the bloodstream to the liver. Once it arrives, the liver cells grab that bilirubin and attach a sugar molecule called glucuronic acid to it, a process called conjugation, driven by a specific enzyme called UGT1A1. This turns it into conjugated bilirubin, sometimes labeled direct bilirubin on a lab report, which is now water-soluble. The liver then actively pumps that conjugated bilirubin into the bile fluid, which flows through the gallbladder and down into the gut. Gut bacteria convert most of it into a compound called stercobilin, which is exactly what gives your stool its normal brown color. A small portion also becomes urobilinogen, which gets reabsorbed and eventually excreted in the urine. This pathway is exactly why a good blood test doesn't just report one single total bilirubin number. It breaks it down into unconjugated or indirect and conjugated or direct fractions. Which one is elevated tells you exactly where in that pathway things are going wrong. If unconjugated bilirubin is high, the problem is happening before the liver has finished processing it. Either too much bilirubin is being produced or the liver's conjugation machinery is lagging. If conjugated bilirubin is high, the liver has already done its job. It processed the waste, but something downstream is stopping it from being excreted properly, like liver cell damage or a physical blockage. This maps perfectly onto the classic three-category framework for jaundice: pre-hepatic, hepatic, and post-hepatic. Now, in pre-hepatic jaundice, the problem is likely overwhelming red blood cell breakdown or haemolysis, which is indicated by high unconjugated bilirubin on the lab report. Other clues may be normal stool and urine color. With hepatic jaundice, the problem is liver cell damage such as hepatitis, cirrhosis, or toxins, and the lab report show a mixed pattern. Both conjugated and unconjugated bilirubin may be elevated. This may be paired with other abnormal hepatic enzymes such as ALT and AST. With post-hepatic or obstructive jaundice, the liver did its job, but the physical drain is blocked because the bile salts back up into the bloodstream. They cause severe itching, and because the dark pigment never reaches the gut, the stool turns pale, while the backed up pigments get filtered by the kidneys, turning the urine to a dark tea color. If we suspect pre-hepatic jaundice, specifically hemolysis, where red blood cells are breaking down too fast, bilirubin alone is not the whole story. We pull in a supporting cast of blood tests to confirm it. LDH, or lactate dehydrogenase. This enzyme is released when red blood cells rupture, so it rises right alongside the unconjugated bilirubin. Haptoglobin. This is a protein that acts like a sponge, mopping up free hemoglobin released from the broken cells. It gets consumed faster than the liver can replace it, so its level plummets, sometimes to completely undetectable levels. Reticulocyte count. These are immature red blood cells. The bone marrow ramps up production to compensate for the cells being destroyed, so this count spikes. Put together, a classic haemolysis pattern is a genuinely elegant thing to see on the lab bench. Unconjugated bilirubin up, LDH up, haptoglobin down, and reticulocytes count up. It's an internally consistent pattern across 4 completely different tests, all telling the exact same story. Bilirubin also comes up constantly in a completely different context: newborn babies. Neonatal jaundice is incredibly common, affecting a majority of newborns in their first week of life. This happens largely because a newborn's liver enzyme systems, particularly that UGT1A1 conjugation enzyme, are not fully mature yet, combined with a naturally higher red blood cell turnover rate. In most cases, this is purely physiological and resolves on its own within a week or two. But we watch it incredibly closely and sometimes treat it with phototherapy. Why? Because significantly elevated unconjugated bilirubin in a newborn carries a massive risk that doesn't apply to adults. It can cross the immature newborn blood-brain barrier and cause connectors, a rare but severe and irreversible form of brain damage. This is exactly why newborn bilirubin levels are tracked on highly specific age in hours nomograms rather than a standard adult reference range, and why rapidly rising levels trigger an immediate medical response. Now, before anyone panics about a mildly high bilirubin on their own adult lab report, there is one cause that is extremely common and completely benign: Gilbert syndrome. It's caused by a genetic variation in that exact same UGT1A1 gene responsible for conjugating bilirubin. In people who inherit 2 copies of this variation, their conjugating enzyme activity can drop by about 50%. And it's quite common. Literature puts the general population prevalence around 10%. That means a meaningful chunk of everyone watching this either has it or knows someone who does. It causes mild, intermittent spikes in unconjugated bilirubin, often triggered by fasting, illness, dehydration, or stress, but it does absolutely no damage to the liver. It doesn't progress and it needs zero treatment. It's the #1 reason for a mildly abnormal bilirubin in an otherwise completely healthy person. Gilbert syndrome sits at the mild end of a spectrum of inherited bilirubin disorders. At the severe end is Crigler-Najjar syndrome, where the conjugating enzyme is either entirely missing or severely defective, requiring intensive pediatric management. On the conjugated side, conditions like Dubin-Johnson and Rotor syndrome impair the liver's ability to excrete the already processed bilirubin. While these are quite rare, they beautifully illustrate the rule. Exactly where in the pathway the genetic defect sits determines exactly what pattern shows up on your lab report. This is exactly why a fractionated bilirubin result is so clinically powerful. Before anyone orders a CT scan or an MRI, this one simple, inexpensive blood test can localize the problem to hemolysis, liver damage, or a physical blockage. So just a quick recap. Bilirubin comes from red blood cell breakdown, gets conjugated by the liver, and excreted into the bile. Whether the unconjugated or conjugated fraction is elevated tells you whether the problem is pre-hepatic, hepatic, or post-hepatic. We use tests like LDH and haptoglobin to confirm true hemolysis. We watch newborn bilirubin closely to protect the brain, and we recognize Gilbert syndrome as a completely harmless quirk affecting 1 in 10 people. If you haven't already, go watch my full breakdown of the other liver function tests. It is the perfect companion to this video, and if this made a confusing medical topic click for you, hit subscribe and share the video. With that said, thanks for watching, and I'll see you in the next one.